For nearly 70 years, the old Clark Bridge was the most direct route from Alton, Illinois to St. Louis, Missouri. But the old bridge had become a bumpy traffic bottleneck. Everyone agreed a new bridge was needed. Building a bridge across the mighty Mississippi would require expert project management skills. Projects are special operations designed to accomplish a set of objectives in a limited time frame. Managing projects involves identifying tasks, making time estimates, projecting resource requirements, and preparing budgets, then monitoring progress and revising plans as needed. Effective scheduling techniques are vital to the success of such a project. Time is money, and the state of Illinois underscores this fact with a $4,000 per day late penalty to its construction contractors. It's also important to organize tasks in the proper order to ensure the project's success. This project began with the bridge design. The designers chose a cabled-stayed span bridge for its strength and low cost. It's a design that had never been attempted quite like this anywhere in the world. Before construction could begin, the state had to break down the job and award contracts. Work breakdown structures help project managers determine exactly what needs to be done so that they can estimate how long it will take. A hierarchy of activities is established. In this case, the state divided the bridge up into sections and awarded each section to a different contractor, which encourages more competitive pricing. The total budget for the bridge was $86 million, and the deadline was 3 years and 5 months away. Bridge construction presents special challenges.
Working over water is one of the toughest things you can do. You have to plan every morning, which we do. We meet every morning with the staff for just a few minutes because you can't just walk out and take something or drive out and get somebody. Everything has to be maneuvered by tugboats and barges.
When undertaking such a large project involving thousands of tasks and multiple contractors, scheduling becomes a critical element. One of the most popular techniques for scheduling is a Gantt chart. The Gantt chart uses layers of timelines indicating activities, durations, and dates. This Gantt chart was created by Massman Construction to schedule work on the Missouri approach. The state of Illinois required each contractor to submit Gantt charts in their progress reports. Construction of the bridge began in the center of the river, grounding a foundation frame and enclosing it with steel walls to create an enclosure called a cofferdam. Then it was filled with reinforcing steel and concrete. The Missouri approach required a rather unconventional foundation, one built on stilts to avoid the dangerous high pressure in the deeper water. Unusual tasks like this are more difficult to schedule and budget, especially when so many unforeseen things can go wrong. The holes in the bottom of the cofferdam needed to be plugged by divers. Work hit a snag when sections of reinforcing steel were dropped in a 30-inch steel piling. Divers worked all day to fish these sections out of the bottom of the 60-foot deep tube. This was one of many bumps in the bridge's schedule. When the main span foundations were finally finished, it was time to build the 300-foot towers. McCarthy Brothers Construction had less than 1 year to finish them. Each morning, the crew was taken by barge to the site. In 3 months, the towers were 70 feet tall, increasing the exposure of the concrete forms to the fall winds. Though the winds stopped work on the towers, construction continued independently on the ground, where the crew assembled the tower's reinforcing steel. Specifications for the custom tapered towers required different measurements for each steel bar, which took extra time. They carefully moved these heavy forms into place, spliced each bar to its mate, and poured another higher section of concrete. But this concrete failed the state's quality test.
I took a hammer and chipped some of the concrete off the surface, and I noticed that it was very soft, it was very lightweight. I took a sample down with me to the field office, and I noticed it was so lightweight it would actually float on the water.
More than 215 cubic feet of concrete needed to be removed, and fast. all tower work was shut down. The natural reaction was to rush to catch up, but that can be dangerous. And late in the year, the fall weather increases the danger and the delays. Spring finally arrived, and the cable supporting crowning sections were added to finish the towers. The Illinois Approach contractor got a late start. Then a crane tipped while trying to lift an oversized load. They fell further behind when the excavator hit an old sunken barge while excavating for the underwater foundations. They decided to cut a huge steel square out of the old barge to make room for the foundation. The schedulers, in turn, had to make room for this costly delay. When the stakes are this high, accurate scheduling can save millions of dollars. PERT, or Performance Evaluation and Review Technique, and CPM, or Critical Path Method, are two of the most widely used techniques for scheduling large, complex projects. They display the sequential relationships among activities and reveal which activities must be completed on time. Both PERT and CPM use deterministic and probabilistic time estimates. Deterministic estimates are used when activity times can be fairly well established, while probabilistic estimates are used for activity times that are less certain. They're useful in coping with unpredictable winter weather and untested procedures, such as installation of the bridge's innovative cable stays. In the summer, 2 years after the construction began, it was time to install the bridge's 112 miles of cable stays. The untested techniques they used for the installation proved costly.
We took it apart and looked at it, and this is what we found. This coating that's on the cable stays is very abrasive, and as one cable was pulled across the other, it actually cut into the cross-sectional area of the steel itself, which would detract from the strength of the cable.
Before the problem was finally resolved, a month and a half was wasted, as well as thousands of feet of cable.
Now we have developed a system of pulling the cables out individually and then putting them all together and pulling all of them together through the banana pipe. So they only make one trip through the banana pipe and they don't wear on each other.
Everything was then ready for the building of the road deck. Sequential relationships are obvious here. They couldn't build the road deck before the towers, or the towers before the foundation. A similar sequence relationship was involved for road deck construction. First, they scheduled for installation of the steel girders, and then concrete roadway slabs. As the road deck grew, disaster loomed. A section of the cable failed corrosion tests, threatening major rework for cable replacement. But the problem was an anomaly, and most of the rest of the cables were approved, to everyone's relief. With much of the road deck in place, it was time to close the gaps, and the bridge was vulnerable to weather damage until the gaps were closed. Surveyors had to check for movement of the two sections and for proper fit. The crew rushed to fit the final girder before the midday heat expanded the bridge. It fit, and everyone was feeling optimistic. All of the problems have been solved to that point.
One thing about this structure, for the size of it and for the dollar cost, which is right at $85 million, there haven't been any major problems that we couldn't solve. My boss said this could well be the first bridge built across the Mississippi on budget and on time.
But then it rained, and rained, and really rained. The construction site was underwater. The flood was the worst in 500 years, with dozens of people dying and billions of dollars in property damage. Little work could be done until the waters finally subsided in mid-September. Schedules and budgets required major revisions and crashing. Crashing is a scheduling technique for shortening normal schedules through the use of additional resources or by transferring resources from other activities. The big question is, when does the cost for the time saved exceed the benefit? As work resumed, schedules were crashed in various ways. It was a race to the finish, with crews working 16-hour days. Trouble on the old Clark Bridge held up the concrete trucks delivering the final loads of special concrete. A suicidal man was threatening to jump, and no one could cross as authorities talked him down. The concrete pour had to be postponed till the next day, but then it was over 95 degrees, which was too hot for the special concrete. The concrete plant mixed in ice with the concrete, and the crew was able to complete the pour. With the road deck finished, the main bridge structure was complete, but many details remained to be finished. Finally, on January 4th, after 3.5 years of construction, the crew took one last walk across the bridge. Bottom line, a magnificent bridge was built, and everyone can be proud of their work. The completion was late, but not by much considering the flood, and the budget overage was only 2%. Project management techniques like work breakdown, scheduling, and budgeting were critical in every step of the construction, especially for adapting to changes. Project management techniques are very helpful for all types of projects, but they are limited by the quality of the information used. As with most systems, if you put garbage in, you'll get garbage out. The dedication ceremony was a month later and much colder than had been expected, but it was a jubilant occasion nonetheless.